Take a moment to look at your reflection. The color of your eyes, brown, blue, green, or something in between, is the result of a subtle, ancient game of physics and pigment. This isn't just decoration. This is a story, a tale of human migration, a massive genetic mistake, and 1 billion years of evolution. Your eye color is determined by one single factor: melanin. It's the dark pigment that shields your skin and hair, and in your eye's iris, it functions as a biological UV filter. The more melanin you have, the darker your eyes appear. The less you have, the more you see the world through a window of pure physics. For most of human history, there was really only one eye color: dark. It was the correct, necessary setting for survival. But as our ancestors left the bright equator and scattered across the globe, the selective pressures changed, and with them, the color of our eyes began to fracture. Let's meet the champions of this evolutionary arms race. Divided into 3 fundamental categories. Brown eyes, the global defense system. Over 70% of the world's population shares this color. If eye colors were a democracy, brown eyes would be an unshakable dynasty. And for good reason. They're the most perfectly engineered eyes for Earth's original environment. Brown eyes are the biological sunglasses. Their high melanin density acts as a dense, dark shield, absorbing harmful ultraviolet or UV radiation and reducing glare. For early humans in the blinding, sun-exposed African savannas, this trait was a non-negotiable evolutionary advantage. It helped preserve visual clarity and lowered the risk of sun-related damage like photophobia and macular degeneration. Unlike lighter eyes that reflect light outward, brown eyes draw it in, ensuring visual endurance under the harshest daylight. They're stable, reliable, and functional. They're the tried-and-true workhorse of human vision. The defense brown eyes offer is more than skin deep. Melanin isn't just in the iris. It lines the back of the eye, specifically the retinal pigment epithelium, or RPE. This layer acts as a waste disposal unit and thermal regulator. In dark eyes, the abundance of RPE melanin effectively absorbs stray light, reducing internal reflections that could blur vision and shielding the delicate photoreceptors from thermal damage caused by intense sunlight. The widespread dominance of brown eyes isn't just a statistical fluke, it's a genetic memory. For hundreds of thousands of years, this was the necessary code for the survival of the species. Lighter eyes were not only vulnerable, but actively disadvantaged, leading to their almost complete absence outside of highly sheltered environments until that massive genetic shift occurred. Black eyes, the absolute absorber. These aren't truly black, but rather an extreme concentration of dark brown melanin. If the brown eye is an excellent pair of sunglasses, the black eye is a welding mask. This dense saturation offers maximum protection against sunlight and glare, making them functionally superior in constant equatorial UV exposure, particularly in parts of Africa, South Asia, and Southeast Asia. They stay visually stable in all conditions, absorbing nearly everything. The trade-off? Their depth minimizes expression, making them intense but often difficult to read. They're the ultimate shield, but they pay the price of emotional transparency. As our ancestors journeyed north, protection became less important than sensitivity. They faced long winters, dark forests, and minimal sunlight. The evolutionary pressure shifted from keeping light out to letting light in. Blue eyes, the light harvester. Blue eyes trace back to a single genetic mutation that occurred 6,000 to 10,000 years ago, effectively turning the melanin production in the iris down to zero. The blue color you see isn't pigment, it's physics. It's the same effect that makes the sky look blue, Rayleigh scattering. When light hits an iris lacking melanin, it scatters off the clear structural fibers. Because blue light is scattered more easily than other colors, your eye reflects it back out. This structural trick allows far more light to enter, enhancing vision in dim conditions, a massive advantage for survival in darker, northern climates. But here's the trade-off, delivered by the same physics. With minimal melanin, blue eyes offer zero protection against UV rays, making them highly sensitive to bright light. They're the best low-light sensors, but they require protective intervention in the sun. But if blue eyes are so vulnerable to the sun, why did they spread so rapidly across Europe? Scientists believe it wasn't just adaptation to low light, it was sexual selection. The sudden appearance of a radically different, light-colored eye in a small, isolated northern population created a startling novelty. In those small groups, this unique trait may have been perceived as attractive or exotic, leading to preferential mating. This theory suggests that the trait spread quickly through social and sexual advantage, rather than purely through improved physical survival. It's evolution's version of a status symbol, the ability of blue eyes to show subtle changes in expression, reacting intensely to light and mood, made them highly visible and emotionally readable in dimly lit caves or during long northern nights. This visibility itself became a driving force, ensuring the survival of the gene. Gray eyes, the silver sensor. Gray eyes are exceptionally rare and even more biologically distinct than blue. They contain even less melanin, allowing light to scatter more diffusely across the iris. This broad light dispersion makes them appear silver or slate, and they're incredibly sensitive to their environment, often appearing subtly green or blue, depending on the light source. Like blue eyes, this trait expanded visual sensitivity in dim, overcast conditions, making them the ultimate low-light adapter. Culturally, their cool neutrality and visual stability have often made them associated with wisdom or emotional control. Not all eyes chose the extreme ends of the spectrum. Some developed a complex balance of pigments, creating adaptable, chemically diverse colors perfectly suited for variable climates. Green eyes, the temperate zone. Found in only about 2% of the population, green eyes strike a rare evolutionary balance. They have just enough melanin to offer moderate protection, mixed with a secondary yellow pigment called lipochrome. The hue you see is the result of this precise pigment blend interacting with the blue Rayleigh scattering effect. Too much melanin would make them brown. Too little would make them blue. This instability means the color is highly sensitive to light, often appearing mossy in shadow and golden green in sunlight. This visual adaptability may have helped early humans thrive in temperate climates with variable lighting, like mixed forests and mountain regions. Their rarity and shifting tone have long made them a focus of folklore, associated with mystery and intuition. Hazel eyes, the chameleon. Hazel eyes offer versatility, sitting between light and dark on the melanin scale. They contain intermediate levels of melanin and traces of lipochrome, allowing them to shift from green to gold to brown, depending on lighting and surroundings. This dynamism is their core evolutionary advantage, making them especially adaptive in mixed light regions where conditions change often. They represent a genetic blend, a bridge between the dark-eyed shield and the light-eyed sensor, making them one of the most chameleon-like and emotionally expressive eye colors in the human population. Amber eyes, the predator's gaze. Amber eyes are extremely rare and are marked by high levels of lipochrome and with very little melanin, resulting in a stable golden, copper, or honey color. Unlike hazel, amber eyes do not change with lighting. They stay richly golden under all conditions. This striking and uniform coloration is also common in predatory animals like wolves and owls, which may be why some researchers suggest humans subconsciously associate this color with alertness or confidence, traits that would offer subtle social and psychological advantages in group dynamics. But what happens when the genetic code gets scrambled? Heterochromia is the condition where an individual has two distinctly colored eyes, or significant color variation within a single iris. In most people, melanin is distributed symmetrically. Heterochromia occurs when that symmetry is disrupted, often due to a minor genetic mutation or typo during early development. It's a fascinating failure of symmetry, a genetic mosaic. While not adaptive in the traditional sense, this rarity highlights the astonishing complexity and developmental fragility of pigment inheritance. Historically, heterochromatic eyes have been seen as signs of duality, mystery, or even supernatural connection. So, is one eye color better than the others? No. No single eye color is the best. Every color you've seen is an evolutionary compromise, a finely tuned solution to a specific environmental problem. Brown eyes won the fight against the sun. Blue eyes won the fight against the darkness. And the rarities are beautiful evidence of the constant, ongoing, and chaotic genetic experimentation that defines human life. Your eye color isn't just a physical trait. It's a living record of where your ancestors survived, what challenges they overcame, and the random, brilliant mutations that allowed you to see the world today. Your vision is a miracle, and its color is history.